In this example, we are told that when a surgery is used to repair a torn tendon, infection occurs 3% of the time, repair fails 14% of the time, and both happen 1% of the time. I'm going to name the events. Notice that there's a difference between the events, the number of things in the event, and the probability of the event. So after naming these events, the two main ones that we're told about at first, and then the 1%, that's the probability of A and B both occurring. So what if we were asked, what's the probability of at least one of these things occurring? Because that 1% is included in both event A and event B, then we should label the percent that's in the intersection first. In other words, don't put that 3% there. Instead, put the 1% in the intersection and take away 1% from the 3% to get the 2%. So similarly with B, the probability of B, we had, I think it was 14 or 13, but we're going to take away the probability of the intersection from that to fill in what's in the remaining parts. That 14% applies to all of B. So there's 13% of the time where only event B occurs and event A does not. So we can total those up. 2%, 1%, and 13%. And this is going to give us the probability of A or B, i.e. the probability of the union. It's going to be a total of 16%. I'm going to show something else in the Venn diagram in just a moment. The probability that neither happens, A does not happen and B does not happen. That event, according to one of De Morgan's laws, is the complement of the union. And so the probability outside any part of any circle there, we should see 84% showing up in just a moment. So let's go back to that, see if I included that. There it is. Okay, now, if you had more than two main events, eventually using a Venn diagram is going to get cumbersome. So there's another option. General addition rule, or as other authors refer to it, it's a formula that goes along with the principle of inclusion, exclusion. So A intersect B is included in both of these. So it's getting counted twice, take it back out once. Let's look back at those numbers here real quick, because what you do not want to do, you don't want to fill in probability of A and B with what you had from the Venn diagram. These are instead two different methods for avoiding double counting. You don't mix them. So we've got 3% 14%. And what's being taken away is the 1% that's in the intersection. That also is going to give us 16%. Now we've lost some information compared to the Venn diagram, but we could still find out the probability that neither A nor B happens. A complement intersect B complement, we could still find out that that's 84% based on what we just computed there.